In last week's lessons, we learned how to write a linear regression model from a scatter plot by hand, using Excel, and using Desmos. Now we are going to create a quadratic model using regression. So that means when we graph the points, they don't appear to make a straight line, they appear to make a parabola, either shaped upward or pointing downward. So as you can see in this case, I've already done the regression, but I'm going to show you step by step how to do this in Excel. So what I'm going to do is, just as before, I'm going to find my values, my table of values, and I'm going to copy and paste those into Excel. Notice that I have pasted those values into Excel, and now I'm going to highlight those columns of X's and Y's. To make a scatter plot, just as before, insert, and then choose the scatter plot where the lines are not connected. So here I have a scatter plot where my lines are not connected. I'll make it a little bit bigger for you. And before we drew in our own line, but in this case I will not, because I want Excel to do all of the work. So I'm going to double click on my function, and I'm going to add a trend line, but it's not linear or exponential. As you can see, it wouldn't fit any of those lines. So I'm going to go to more options, and I'm looking for a quadratic, which means it's a polynomial, and the degree is 2, because we know a quadratic, the highest degree is 2. So polynomial degree of 2 gives me a parabola, in this case an upside down parabola. In addition, I want the equation displayed on the chart. So notice down here, very small on the bottom, they have given me that equation. The question asked me to find the model to 3 decimal places. So as you can see, I've taken the information that they've given me within Excel, I've rewritten it so that it is rounded to 3 decimal places, and this would be my model. Again, what's the point of making a model? Because now I can use this equation to make predictions for, say, when x is 30, I could predict what y was going to be, rather than looking at the values on the table and just guessing. So we'll do a little bit of predicting in another example in a moment. First, I want to show you how to do the same process in Desmos. So again, in Desmos, we're going to do just as we did before. We're going to take the values from Excel and copy and paste them so that it makes a scatter plot for us. Now that I'm in Desmos, I'm going to click in the box and simply paste my data. Notice it's x1, y1s. Now that I have my scatter plot, I want Desmos to do all of the hard work, but I have to tell Desmos what to do. So on my next line, I'm going to start the standard form of a quadratic function, which is y equals ax squared plus bx plus c. Instead of y, I'm using y1, so that Desmos knows to please use the values from y1. As before, I'm going to use that little squiggle line, which tells Desmos that it's got some work to do. And then a, and instead of just x squared, I have to say x1 squared. And then plus b, and then again x1 plus c. So now notice it's drawn in a quadratic model, and the a value is negative 0.034485. The b value is 2.7929, and the c value negative 14.285. If you'll remember, that function is exactly the same as the function that we had within Excel. Same function, Desmos and Excel, which means they're doing the same thing, they're doing it correctly. So I want you to try one. Use either Excel or Desmos. You do not need to use both. Write down what the quadratic function is, and then we're going to answer B and C. You can try them on your own first, or you can wait for me to go through those with you. Use the data on the table, and then press play to check your work. I have chosen to use Desmos to write my model. So as you can see, I've entered in the values from the table, and I've let Desmos do the work. Notice in this case, because I pasted on top of my other function, my table values are now x2, y2, and so in order to make that work, I had to change my x's to x2s and my y to y2. So now I'm going to use the values for a, b, and c to write my function. So I will do that back on the PowerPoint page. So now I've written my model from Desmos. You could use the same thing with Excel. This is the model that gives me the best fit line, which is a quadratic line, for the data points that I gave. It asks which year the funding is the least and round to the nearest year. So notice, again, when we graphed this one, it made a nice parabola that's pointing upward. So if it's looking for that least value, that's going to be the vertex. So usually when they're asking for least or greatest, that's the vertex. So I'm going to find the x value, because that's the year. T is years. So I'm going to find the x value, which is the opposite of b, over 2a, and do the math in my calculator. Using my information from Desmos, I now have my quadratic model of the data. I'm going to use that model now to answer some questions. So whenever you're using a model to answer questions, it's important to pay attention to what f of t stands for, which in this case is millions of dollars. So this is millions of dollars. And t represents years. Oh, I guess this should be t and f of t. So I'm trying to find the year in which the funding is the least, which of course means find t for the least amount of funding. Well, we know that when we graphed this, it turned out to be a parabola that was pointing up, which means the least amount of funding is just code for find the x value or t value of the vertex. So remember when we did that before, that was the opposite of b, so positive 0.577 over 2a. So I'm going to use my calculator to do that calculation. And I get about 4.89. Now notice it says round to the nearest year, and so I would say rounded to the nearest year, that's about 5 years. So during what year? It's 5 years after we started keeping track. So in general, one of these, they would say that t represents years since some certain date. Since they don't tell me that in the information, then I'm just going to say in 5 years. What is the minimum yearly amount of funding received? So that means when it's at the minimum, what's the y value? So that means I'm going to take f of 5. Now f of 5 where? Does that mean just look at the table and say, well, it's between 2.1 and 2.2 million? No, I'm going to use this function that I came up with. So I'm replacing, every time I see t, I'm replacing it with 5 because they did ask me to round that to the nearest whole year. So use your calculator to do that calculation. So in doing the calculation, I came up with about 2.01. They do ask me to round to the nearest million, so I would say it's about $2 million. Again, I could find that out looking at the table. That one wouldn't have been quite as difficult since it's f of 5. So we knew it was going to be somewhere in here, but it's about 2 million using our function.